Hi, I am Akash. In this video I present a trade study on Nimble Robotics, an intelligent robotics fulfillment startup. Nimble Robotics is a startup that is focused on developing intelligent robotics solutions for the logistics industry. It offers a fleet of intelligent robots to replace expensive and inefficient human workforce. It claims its robots can pick and pack anything including cloths, shoes, and other small items. So far it has handled more than 500,000 of different types of products. The company offers single-day integration with zero initial setup costs. Further, its robots can perform intelligent dense packing of the items. Nimble Robotics was founded in 2017 by Simon Kalush while he was enrolled in a PhD program at Stanford. He eventually dropped out of the program to focus on the startup. The company has raised a total of $50 million in funding in Series A. Simon holds a master's degree from Carnegie Mellon University and a great background in robotics and machine learning. Simon successfully roped in his PhD advisors Sebastian Thrun and Dr. Fei-Fei Li. Sebastian has been associated with many companies and startups and brings great expertise in robotics and AI. Dr. Fei-Fei Li is the director of the AI lab at Stanford and has an expertise in computer vision and deep learning. The core team consists of 17 members with backgrounds in computer vision, robotics, hardware, software, and operations. Other than the board directors, only one member has a PhD degree. However, majority has a master's degree with substantial industrial and research experience. At present, Nimble has a total headcount of 122. The patent filed by Nimble in 2020 provides some insights on how their systems works. As per the patent, manually picking and placing each product in the bin is labor-intensive, expensive, and inefficient. The reason why companies have not adopted robots in fulfillment is due to the initial high setup costs, as setting up a new system with robots typically requires changing the existing infrastructure and warehouse codebase. However, Nimble robots are designed to assume the role of the human operator and use the same system that is typically used by manual operators. This means the robot needs to use the existing interfaces and instructions to carry out the task. First, the robot captures the image of the display and parses out the instructions using visual instruction recognition program. Once the instructions are parsed, the robot executes the pick and place functions. The pick and place functions need to locate the object in the bin and assess the texture to select the appropriate end effector before picking up the item. Once the item is identified, the robot performs the operation and feeds the feedback to the system using a push button. Originally designed for humans, artificial intelligence has been used at various stages in this product. Although no associated publications or patents were found, the website hits that the product uniquely fuses robotics, computer vision, deep imitation, self-supervised, and reinforcement learning. Computer vision and deep learning methods are used for three aspects. First, to get the task instructions from the captured images, and then to segment and identify items in the bin. The identified object then needs to use a classifier to select the appropriate end effector tooling, suited to its texture. Once the item is located, and tooling is selected, the robot needs to perform robot motion planning to execute the given task. Further, the robot needs to optimize the packing of the items to save space. This video focuses on object identification, segmentation, and tool selection part. Now I describe the speculated AI architecture for the pick and place task. Once the robot gets the instructions, it captures an image of the bin. The image is then fed into a deep learning model to identify and segment the items in the bin, potentially using algorithms such as you only look once and RCNN. The segmented items are then fed into a deep learning classifier. and the input to the convolutional neural network is the image of the single entity. The network performs multi-class classification to choose one of the three end effectors appropriate for the object texture. Once the tooling is selected, the robot performs robot motion planning to execute the given task. The robot then confirms the packing and continues with the next task. The computer vision and deep learning models most likely are based on large pre-trained models on large image datasets. The models can then be fine-tuned to this specific task by using transfer learning with a small dataset. Further, the data generated by the robot can be used to augment the data and improve the models. For motion planning, the robot can use model-based reinforcement learning on simulated data. The robot can then use the learned model to plan the motion in the real world. Nimble claims 99.9% production accuracy. Metrics can include the success rate and completion time. Nimble provides seamless single-day integration with zero code changes in the existing software. One of the goals of the company is to replace the expensive labor. However, it does not hold any accountability towards the workers. It should provide training to the workers to prepare them for this job shift. Further, the models are not fully interpretable. Overall, the company has an excellent team of experts. Implementation and execution are two main factors that differentiate the company from others. The startup has made a good progress and I recommend investing in it. Thank you for watching.